compounds which contains rings of 3 or more carbon atoms connected by single double bond and resemble aliphatic compounds in their properties. All the alkynes will be having the same chemical properties, right? Next is OH group. OH is hydroxyl group, which is the alcohol. The Latin name of ant is Formica. Hence, the acid which is present in ant is named as formic acid. Hello everyone, this is Ambli Unnikrishan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So today we are back with session 2 of the chapter Organic Chemistry, right? So in the last session we discussed about the introduction. Yes, we saw that what we are going to study in this chapter, right? The introduction of it. And then we went into the detail about the carbon atom, right? The tetravalency of the carbon atom, the catenation property, isomerism, all that, right? And then hybridization and bond characteristics we studied. And then the structural representation of organic compounds. The various ways in which the structural representations can be done. The complete structural formula, condensed structural formula, bond line, and the 3D representation as well as Lewis representation were also discussed in the last session, right? So in today's session, we are going to study about the classification of organic compounds, how the organic compounds are classified, right? And then we will be studying about homologous series. And then we will begin with the nomenclature of organic compounds, okay? The introduction of the nomenclature we'll do in this session, right? So the first part is classification of organic compounds. Okay, so organic compounds, what are organic compounds? We know that. Now how they are classified, we are going to see. So majorly they are classified into two groups, that is aliphatic organic compounds and cyclic organic compounds. Okay, so the first one is aliphatic or acyclic or open chain compounds. Okay, aliphatic, acyclic or open chain compounds. Okay, so these are compounds in which you do not see any ring-like structure. They will be either straight chain or else branches can be also possible, but there will be no closed structure or rings. Okay, so they are aliphatic. Now coming on to the next group, that is cyclic. Cyclic or closed chain or ring compound. So as the name suggests, they will be closed. There will be a ring-like structure. Okay. So now this aliphatic can be further classified into your alkanes, alkenes and alkynes. Right. You are familiar with already what is alkanes, alkynes and alkynes. Right. So that comes under aliphatic. Now cyclic group or the cyclic organic compounds are further classified into homocyclic and heterocyclic. Homocyclic organic compounds and heterocyclic compounds. Okay. Now what is homocyclic? Okay, in cyclic compounds itself there are two types, homocyclic and heterocyclic. So as the name suggests, Homo means only one type of atoms will be present. Okay, that is in the cycle only carbon atoms will be present. There won't be presence of any other atoms there. All the atoms will be same. That is homocyclic. Okay, now that is the one part, and the homocyclic is further classified into alicyclic compounds and aromatic compounds. Okay, so in detail about all of these groups we are going to study now. Okay, now alicyclic and aromatic compounds. Now this aromatic compounds are further classified into benzenoid and non-benzenoid compounds, right? And then there was one more classification, homocyclic and heterocyclic, right? So what will be heterocyclic compounds then? There will be more than one atoms which is present. Not all will be carbon. There will be other atoms as well as present in the ring. Okay. So this is the classification of organic compounds. Now in detail we are going to study about each of it. Right. So the first classification was aliphatic and cyclic. Right. So beginning with the first one, that is acyclic, open chain or aliphatic compounds. Okay, there you will not find any ring structure. It will be branched or straight chain compounds, right? So these compounds are also called as aliphatic compounds and consist of straight or branched chain compounds. That's it. There won't be any ring structures, right? So the first one you can see, it is what it is. How many carbon atoms are there? There are 3 carbon atoms. It is an alkane, right? So 3 carbon atom means it is propane, right? So alkanes, alkenes and alkynes, you are already familiar with those, right? So this is alkane. Which alkane? It is propane. So as you can see, it is a straight chain compound. right? It is a straight chain hydrocarbon. Are you able to see any branches? In this case, are you able to see any branches? No, it is straight chain. So this is an aliphatic compound, right? Now moving on to the next one, that is isopentane. Isopentane, how many carbon atoms? 1, 2, 3, 4, 5, right? A total of 5 are there. So it is isopentane, right? So in this case also, one branch is there. Even though branch is there, still it is aliphatic, no ring-like structure, right? So now coming on to isobutylamine. Even this is a branched chain compound, comes under aliphatic. Now another example is propene. Propene is an alkene, right? Double bond is there. Now propyne, it is an alkyne. All this comes under aliphatic. Okay, all straight chain and branch chain compounds come under aliphatic hydrocarbons or aliphatic organic compounds, right? Now the next one is cyclic. Right, cyclic or closed chain or ring compounds. So the compounds in which carbon atoms are linked to each other to the atoms of other elements in closed chain or ring-like structure. They will be bonded with each other and they'll form a closed structure. Right, not open, it will be closed. Okay, now there are two types. First one is homocyclic and the second one is heterocyclic. So in the homocyclic, compounds which contain ring made up of carbon atoms only. Okay, only carbon atoms, they are called as homocyclic. Okay, they will contain only carbon atoms which is present. Let us take this example itself of cyclopropane. Okay, in all these joints that you can see, it is just carbon atom. In the cycle or in the ring structure, are you able to see any other elements or any other atom? No, right? All of these are carbon. So such compounds are called as homocyclic compounds. And now homocyclic compounds are further classified into alicyclic and aromatic, right? So the first one is alicyclic compounds, right? The compounds which contains rings of 3 or more carbon atoms connected by single double bond and resemble aliphatic compounds in their properties. Okay, so it is homocyclic. It comes under homocyclic, means that is they also do not have any other atoms present in their ring structure. But why they are called alicyclic? Because they have properties which is similar to the aliphatic compounds. So such compounds are called as alicyclic compounds. So the first example you can see cyclopropane. Cyclopropane, right? We saw the structure of propane here, right? Now if it is in the form of the ring structure, it becomes cyclopropane, right? It is cyclopropane. Now this is cyclobutane. This is cyclopentane, cyclohexane. Yes, in cyclohexene it is. You can see a double bond as well, right? So in all these examples, they are alicyclic. Now moving on to the next part, that is aromatic compounds. Yes, homocyclic further classified into alicyclic and aromatic. Now the next one is aromatic. This is compounds consisting of at least one benzene ring. Okay, so aromatic compounds will have to contain at least one benzene ring. So why it is called aromatic compounds? Because this aromatic compounds will contain a particular smell. Aroma will be there. Okay, they have a specific smell. That is why they are called as aromatic compounds. Okay, so such compounds will have at least one benzene ring, and aromatic compounds are further classified into benzenoid and non-benzenoid compounds. So the first one is benzenoid. Benzenoid means they will contain benzene ring. Aromatic compounds consisting of at least one or more fused or isolated benzene rings are called as benzenoid compounds. So the examples you can see, right? Phenol. Okay, on a benzene ring, there is a OH group which is attached, right? So that is phenol. Right. Now anthracene, 3 benzene groups attached together, fused together. That is anthracene. Okay. Now this is naphthalene, 2 benzene rings together. Now next one is toluene. On a benzene ring, if there is a CH3 group, methyl group present, that is called as toluene. Then your benzene, all these are examples of benzenoid compounds containing benzene rings. Now there are non-benzenoid compounds. They are aromatic compounds without the benzene ring. Okay, they are aromatic compounds without the benzene ring. Few examples of these are propylon, propanone and azulene. All these, as you can see here, they do not have benzene ring, but still they are aromatic compounds because they have that specific aroma. Okay, that is why they are called as aromatic compounds. So I hope the classification is clear till here. Now there is one more group. Which was it? Heterocyclic compounds, right? Homocyclic was classified into alicyclic and aromatic. Aromatic further into benzenoid and non-benzenoid. Now there was one more group, that is heterocyclic. What is heterocyclic? Aromatic compound. Heterocyclic means in the ring itself more than one atom will be there, right? These are compounds containing ring structures in which one or more carbon atoms are replaced by heteroatoms, nitrogen, oxygen or sulfur, any other atom will be present. So as you can see here, furan, in this case one carbon atom is replaced by oxygen. Okay, thiophene, in this case one carbon atom will be replaced by a sulfur atom. So I hope it is clear, right? Now moving on to the next part, that is functional groups. Okay, now what are functional groups? As you can see, it is a group of something, right? Functional groups. Okay, let's see. Atom or group of atoms joined in a specific manner, which is responsible for characteristics, chemical properties of the organic compounds. Okay, that means there are certain functional groups, which is actually a group of atoms. Let's consider oxygen and hydrogen. They are two atoms. Okay, if they combine together, that is in a specific manner, if they are combining, they form OH. Now this OH, which is called as hydroxyl group, this is a functional group. Okay, so wherever you are seeing this OH group, that belongs to the alcohols. Okay, you are quite familiar with some of the functional groups. OH is alcohol, COOH functional group belongs to the carboxylic acid. CHO is aldehyde, right? So such groups of atoms are called as functional groups. Okay, so there will be many compounds which are having the same functional group. It is not just one compound which is having this, no. So many compounds will be having the same functional group, right? So all those groups or all those compounds having the same functional group will be having those same chemical properties. Right, that is what is written here. They will have a characteristic chemical properties. So whichever compounds is having OH group, that is whichever alcohol, some of their chemical properties will be similar, right? Yes. So as you can see, few functional groups have been discussed here, right? So the first one is alkene, double bond. Okay, double bond, wherever you see it is alkene, right? Then triple bond is alkyne, that is another functional group. So all the alkynes will be having the same chemical properties, right? Next is OH group. OH is hydroxyl group, which is the alcohol, right? Now NH2 is amine, right? CHO is aldehyde, right? And C double bond O, it is called as ketone. Right. So all of these are examples of functional groups. There are other functional groups as well as COOH, which is quite familiar to you. That is carboxylic acid, right? Yes, as you can see here, COOH is carboxylic acid. How do you represent it? RCOOH. So what is this R? This R is any methyl group. For example, let us write CH3COOH. What is this called as? This is acetic acid, right? CH3COOH. Okay, or else you can also call it as ethanoic acid, right? Okay, so that R can be CH3, C2H5, C3H7, any alkyl group it can be, right? So that R represents alkyl group. The next one is COOR. Now what is COOR? It is ester. How do you represent the general formula? RCOOR. So that R, that is this R is alkyl group, even this is an alkyl group, right? Now next one is CONH2, that is amide. RCONH2, which is the general formula, that is R C double bond O NH2. Okay, so as NH2 group is there, it is amide. Okay, not amine, it is amide, right? Then COCl, acid chloride. Okay, as you can see, there is a halogen atom also present, so it is acid chloride. The next one is CN. Okay, CN functional group is for nitrile. How can you generally write it? RCN, right? The next one is NO2. It is nitro. OR, it is ether, right? So the general representation is ROR. It is shown R dash here because the alkyl groups can be same or else different also, right? Now the next one is X. What does X stands for? This is for halogens, fluorine, chlorine, bromine, iodine. Okay, so halogen compounds, which is generally represented by RX. What does this X stands for? X stands for the halogen groups and the R stands for the alkyl. So these are the few functional groups which you have to be familiar with. So when we are going to study in detail about the nomenclature and the properties and the reactions and the all those things which we are going to study in detail in the chapter, all these functional groups will be more and more clear to you. Okay, right. So now moving on to the next concept, that is homologous series. Okay, so a group or series of organic compounds, each containing a characteristic functional group forms a homologous series. So let us consider the example of our family itself. In our family, okay, there will be a father, mother, children will be there. There will be babies, there will be school-going children, there will be adults, those who are going for job, right? There will be grandparents as well, right? So there are different groups of people, but all of them belong to the same family, right? Yes, I hope it is clear what I was trying to say. Okay, so all this age group people from the baby to the grandparents, all of them belong to the same family. So all of them will have some characteristic property. All of them are belonging to the same family, means some similarities will be there between each of them. Okay, even though they are different person. Okay, the baby and the grandparent or the baby and the father is two different people. Right, two different persons, but still they are belonging to the same family. So we can say them as a homologous series. Right, so coming on to chemistry, a group of series of organic compounds, each containing a characteristic functional group. That means all of these compounds that is coming in a homologous series, all of these compounds will be having the same functional group. Okay, but they are different compounds but having the same functional group. Hence, they will have some similar chemical properties as well. Right, so successive members differ from each other in the molecular formula CH2. They will differ by a molecular formula by CH2. Right, for example, a homologous series of alkanes, alkenes, alcohols, aldehydes, all these can be there. Okay, so here what I have shown here is a homologous series of alkane. Okay, so in this case all these comes under alkanes. Right, so the first one is CH4, that is methane. The second homologue, that is the next successive member is C2H6. Okay, that is ethane. Now C2H6 and CH4, they are differing by CH2, right? C2H6, okay, and CH4, they are differing by a CH2 group, right? One more CH2 if I add to CH4, it becomes C2H6. So they differ by a CH2 group. The next member is C3H8, that is propane. Again, they are differing by a CH2 group, right? Next is butane, pentane, hexane, heptane, octane, nonane, and decane. So all this comes under the alkanes itself. So this is an example of homologous series. Okay, and each successive member will differ from the previous one with a CH2 group. Right, so this is called as homologous series. This is for alkane. Same way you can write it for alcohols as well. The first member will be methanol. Right, the next member, the next homologue, how you can write it will be C2H5OH. Right, the third member will be C3H7OH. Fourth member will be C4H9OH. Right, so this way you can write. See, in all the compounds the functional group is the same. It is OH itself. It is an alcohol. Right, but still they are differing by a CH2 group. So this series is called as homologous series. Right, so I hope it is clear. Now moving on to the next important part, that is nomenclature of organic compounds. Right, we are going to name the organic compounds, which is very important. Right, okay, so an organic compound has two types of names, that is common name and IUPAC name. Like us, we have an official name, which you have it in your certificates and in your college and everything. You have an official name, right? But maybe your parents at home, they call you with a different name. You have a pet name as well, right? So you have an official name, you have a pet name, which is used at home as well, right? So you have two names. Same way, our organic compounds will be also having common names and IUPAC name. So these common names can be used, but officially what has to be used is the IUPAC name. So this IUPAC name, how to name it is based on the IUPAC nomenclature, which has certain rules. Okay, so this is an international system which is applicable in everywhere internationally. So wherever this organic compound is being discovered, it will be having this official name. Okay, the common name is different, right, and the IUPAC name is different. Okay, now the common name is based on the source or some properties. So how the organic compounds have this common name, that can be based on the source from which it is obtained, or else it can be based on some properties also. For example, citric acid, you are familiar with citric acid, right? Citric acid is present in citrus fruits, right? In citrus fruits it is present, hence the name citric acid. So from the source where it is present, it is the common name. Citric acid, it is the common name, right? It is found in citrus fruits. And the acid found in red ant is called as formic acid, since the Latin word of ant is formica. Okay, right? The ant, right? The Latin name of ant is formica. Hence, the acid which is present in ant is named as formic acid. Okay, so the common name can be based on the source from which it is obtained, or the based on some properties it is having, right? That is the common name. So as you can see, CH4, the common name is methane. Yes, the next one is N-butane, right? Next one is isobutane, neopentane. All these are common names of the organic compounds, right? Okay, now moving on to the IUPAC system. As I said, there must be an official name of the organic compound as well, right? So the IUPAC name or the IUPAC name of the organic compound is based on certain rules which is proposed by the IUPAC, right? Okay, a systematic name of an organic compound is generally derived by the identifying the parent hydrocarbon and functional groups attached to it. This name is called as IUPAC name. That will be, let's consider any organic compound, it will be having a parent hydrocarbon. Okay, and in that parent hydrocarbon, many groups will be attached, functional groups will be there. Okay, so based on that, yes, the IUPAC name will be given to the organic compound. So in general, if we talk about the naming, there can be three parts for an organic compound, that is word root, suffix and prefix. Okay, word root means it is the name of your main parent group. Okay, parent chain, that is the word root. Then there can be a suffix and prefix. Prefix comes before the name of the parent chain and suffix comes after it. Okay, so let's take this example and understand. This is a organic compound which is given CH3, CH3, CH2, CHBr, CHOH and CH3. Okay, so as you can see, the longest chain here, 1, 2, 3, 4, 5, 6 carbon atoms is here. So this is the longest chain. So that chain is called as the parent chain. Okay, this is called as the parent chain. This whole is called as the parent chain. So now in the parent chain, you are able to see certain branches, right? So from this CH, there is a CH3 which is present here, right? So this is a branch. Now this is another branch. This is another branch. Okay. So from the parent chain, any other bonds you are able to see, those are called as branches, right? Now this first branch you can see here, this is a methyl group, CH3. CH3, it is a methyl group, right? Now the next one is, you can see bromine. Now that is a functional group. We studied under functional group. Halogens are functional groups, fluorine, chlorine, bromine, iodine, right? So this is a functional group which is present, right? Now the next one is another functional group is there. OH, alcohol functional group is there, right? So this is how the three parts are present, right? There will be a parent chain, there can be suffix, there can be prefix. Which one will be the prefix and suffix, we will discuss in detail now. So I hope it is clear. There will be branches also present. There can or cannot be branches present, and there can be the functional groups present, and methyl or the alkyl groups can also be present, right? Okay. Now moving on to the prefix. Prefix indicates the substituent. Okay, prefix is written in before the name of the parent chain. Okay, that indicates the substituent group, right? Now the root word, it indicates the number of carbon atoms in the longest chain. Okay, it indicates the number of carbon atoms in the longest chain. In the longest chain, how many number of carbon atoms is present? Based on that, right, the root word will be written, right? Now primary suffix. Yes, as I said, suffix comes in the last. Now primary suffix and secondary suffix is there. Primary suffix, it indicates a saturation or unsaturation. Saturation and unsaturation. Yes, alkanes are saturated and unsaturation or unsaturated compounds are alkenes and alkynes, right? So if it is an alkane, the name of the organic compound will end with ANE, ane. Okay, if it is an alkene, it will end with ENE, that is ene. Okay, and alkyne ends with YNE, right? Okay, now secondary suffix indicates the functional group, and for each of the functional group there is a certain way in which you have to write the name also, which we will be discussing in detail, right? Now certain examples of word roots are given here. So as I said, what is word root? It indicates a number of carbon atoms in the longest chain. Okay, so as you can see, if there is only one carbon atom, the word root will be meth. Okay, so let's take the example of CH4. Okay, only one carbon atom is there. So, yes, which is the word root? It is meth, right? It is meth and it is an alkane. So, what will be the name of this compound? It will be methane, right? Methane, right? Yes. Now, the second one is eth. If two carbon atoms is there, the word root is eth, right? So, let's take C2H6. C2H6. Okay, C2H6 means there are two carbon atoms. So, the word root is eth. Again, it is an alkane. So, ethane it will be. Right? So, based on the word root, you can write the names. If 3 carbon atoms is there, prop. 4 it is there, bute. 5 it is pent. 6 hex. 7 hept. 8 oct. 9 non and 10 dec. Okay, right? So, I hope it is clear. So, let's take another example. C4H10. C4H10. Okay, how do you write? 4 carbon atoms are there means, yes, the word root is bute. B-U-T. As it is an alkane, yes, what will be the suffix? It will be butane. Okay, so these are the few word roots. Now coming on to the prefixes that comes in the beginning, right? So if it is an alkyl group, I told you the general representation is R. R represents the alkyl group, right? So how do you write that name of the alkyl? You have to write. If it is CH3 group which is present, you write it as methyl. If it is C2H5 present, you write it as ethyl. If it is C3H7 present, you write it as propyl. Okay, so in general, I can write it as alkyl. The prefix will be alkyl. Okay, now if NO2 group is present, that is nitro group is present, nitro will be the prefix. Okay, and if halogens are present, okay, the name fluoro, chloro, bromo, iodo, that name should be present as the prefix. Right. Now, suffixes that comes in the end. Okay. Now, if it is an alkane, yes, it ends with ane. Alkene ends with ene. Alkyne ends with wine. Y-N-E. Now, if it is an alcohol, which is alcohol group, OH group, right? So, the name of the organic compound should end with ol. O-L. Right. So, let's take the example of C2H5OH. How do you name this organic compound? OH is there. So, it is clear that it is an alcohol. Now, how many carbon atoms are there? There are 2 carbon atoms. So, it is eth. The word root is eth. Any other prefixes is required? No, right? Functional groups comes as the suffix. No prefixes here. So, in this case, it is eth. The word root is eth and it is ethanol. The word of the or the name of the organic compound should end with ol. Right? So, I hope it is clear. Now, in the case of aldehydes, that is CHO, aldehyde groups, the name should end with AL, al. Okay, let's take the example of CH3CHO itself. CH3CHO. How many carbon atoms are here? 2 carbon atoms are here. Okay, so again the word root is eth and it should end with AL. It will be ethanol. Clear? Right. Now, the next one is ketones. It ends with O-N-E. Ends with O-N-E. And carboxylic acid, it should end with oic acid. Oic acid. Okay. Methanoic acid, ethanoic acid, propanoic acid. Yes, butanoic acid. Like that. Now, amines, it should, that is NH2 group, it ends with the name amine. The suffix is amine. So, I hope the introduction part of the nomenclature of organic compounds is clear for you. There will be common names as well as IUPAC name. And the basic of it is clear for you, I guess. That is, there will be a prefix, right? And the word root will be there and there will be suffix, primary and secondary suffix. So, in the next session, we will study in detail how you are going to name each of the organic compounds. That is, straight chain hydrocarbons, how do you name it? Yes, and then branched chain, how do you name it? For ring structures, how do you name it? All those in detail we will study. So, based on this basics in detail, we are going to study in the next session, which will be more clear for you in the next session, right? So, in the next session, we are going to study about the IUPAC nomenclature of alkanes, straight chain hydrocarbons, and then we will study about branched chain also, how the rules will be there. Okay, as I said from the beginning itself, IUPAC nomenclature, certain rules are there based on which the, yes, naming will be done. Right, and then naming of cyclic compounds also we'll study in the next session. So I hope what and all we have discussed in this session is clear for you. So that's all for today. Thank you.